So we've been looking at the trigonometric functions and defining them by the ratio of sides of a right triangle. We are going to derive some special angles that you're going to need to know and have memorized. And I'll give you some tricks on how to memorize those later on in the lecture. But right here are the objectives for this section. And we're going to find the exact values of trigonometric functions of pi 6, which we learned how to convert radians to degrees by multiplying by 180 degrees all over pi. Pi 6 was 30 degrees, pi 4ths is 45 degrees, and pi 3rds is 60 degrees. So after this lecture, hopefully you'll be able to figure out what cosine and sine of these are. And once we have those by our identities, we can find our other trigonometric functions. I'm going to quickly go through how to use the calculator. Most of this course and exams, portions of your exams that you're taking through Zoom is going to be where you cannot use a calculator. So you got to get these special functions memorized. So we're going to then use a calculator to approximate values of trigonometric functions of angles. And then we'll jump into modeling and solving applied problems involving right triangles. Okay, so let me derive how we get these trigonometric functions at these special angles. So we're going to start out with a 45, 90 degree triangle. So I just pulled up in front of you this triangle. And we know, if recall, that two angles, if we sum them together and they're 90 degrees, they're complementary angles. And so we know that also the sum of all three angles of a triangle is 180 degrees. So if this one is 45 degrees, then this angle across would also have to be 45 degrees. And if we have the same angle of a right triangle, we know then that the sides are going to be the same. And so I don't know if I mentioned it in this class, but similar triangles, so triangles that have the exact same angles, the ratios of sides are equivalent. They'll be equal to each other. So we can come and let's just make this a little easier. Let's define what the side or one of the legs is. And so if we let this angle, or this side of the triangle be 1, make that be 1, then I also know that this leg of the triangle is also 1. And by that Pythagorean theorem, we can figure out what C is. And so by the Pythagorean theorem, we know that C squared is equal to 1 squared plus 1 squared. So C squared is equal to 1 squared is 1 plus 1, so that's 2. Taking the square root of both sides, we get that C is equal to the square root of 2. Now, knowing the sides of this right triangle, we can use our definition of our trigonometric functions to figure out what they are at 45 degrees. And so recall, if it helps you, there's that saying, SOHCAHTOA, that could help you remember the ratio of the sides of the triangle. And so sine of 45 degrees, well, remember opposite, so I'm going to do the bottom angle 45. It doesn't really matter which 45 degrees you choose, it'll be the same, but I'll do the bottom angle of 45 degrees on this triangle. Opposite is 1 all over the hypotenuse, which is √2. Rationalizing the denominator, multiplying by this fancy 1, √2 over √2, we get that sine of 45. Let me just put it up here. We get that this is √2 over 2. So cosine of 45 degrees, we can look at this as, again, the ratio of the sides of this right triangle. if we're looking at the bottom 45 degrees, the adjacent of that angle would be 1 all over the hypotenuse, which is root 2. Again, rationalizing the denominator, we'll get that this is root 2 over 2. Excuse me. Just going to list them up here so we have them in front of us. We could have done this a little differently. We had seen in our last class period the cofunctions. So we could have looked at this as sine of 45 degrees is the same thing as cosine of 90 degrees minus 45 degrees, which ends up being 45 degrees. So we could use that if we wanted to. Tangent of 45 degrees. Well, this is opposite. So opposite of 45 degrees is 1 all over the hypotenuse, which is 1. And so we get that tangent of 45 degrees is 1. Again, there's different ways that we could approach this. We could have used the definition that tangent of 45 degrees is sine of 45 degrees over cosine of 45 degrees, and we would still get 1 there. So we can think of it as a relationship of sides, or we can think of it as rewriting the other trigonometric functions in terms of sine and cosine. So as long as we know sine and cosine, we can quickly derive the other ones. And so the reciprocal function of sine of 45 degrees, that's secant of 45 degrees. Not secant, that was for cosecant. I'm sorry, this is cosecant. So reciprocal of sine of 45 degrees is cosecant of 45 degrees. So this is 1 over sine. If we looked at 1 over sine before we rationalized the denominator, it was 1 over root 2. Taking the reciprocal of that, we get root 2. So secant of 45 degrees. This is 1 over cosine of 45 degrees, which is also root 2. Cotangent of 45 degrees is the reciprocal of tangent. Well, 1 over 1, taking that reciprocal, we also get 1. Okay, so those are 6 trigonometric functions evaluated at 45 degrees. So now we're going to look at our 30, 60, 90 triangle and use that to derive what the trigonometric functions are at 30 degrees and 60 degrees. Oops. Actually, before we do that, I guess I have some problems down below, so let's try those first. So looking at this, finding the exact values of the trigonometric expression, and we just learned what these values were at 45 degrees, and equivalent to the radian of 45 degrees is pi fourths. Let's find the exact value of each of these expressions given before us. So for A, we have cosine of 45 degrees. Cosine of 45 degrees, we just saw that was root 2 over 2. And we saw that cotangent of 45 degrees was 1. So this is root 2 over 2, all times 1, which gives us back root 2 over 2. So looking at B, we have cosecant of pi fourths times tangent of pi fourths. So cosecant of pi fourths, that was 1 over sine of pi fourths. We saw that that was root 2. All times tangent of pi fourths, which is 1. So we get that this back is root 2. Numbering's a little off, or lettering's a little off here, so this should be C. Oops. Actually, no, those are the answers. So those answers, I didn't mean to put them there, but there's the answers. That's what we just did. It's right in front of you. And I just rewrote it out. Okay, so now let's go to that 30, 60, 90 triangle. Okay, so in front of us, we have a triangle, a 60-degree, 30-degree triangle. And in this 30, 60 degree, 30, 60, 90-degree triangle, we have that the hypotenuse is 2. And so let's create a equilateral triangle. And if we create an equilateral triangle, so kind of let's just take the symmetry of this across we can think of the y-axis, we would get this dotted triangle right in here. We're just doing this. This is now 60 degrees in here. And if we did that, then we know that equilateral triangles, they have sides that are equal to each other. So if this side, which was our hypotenuse, was 2, this side is also 2. The reason we're doing this though is so we can figure out what A is. And if we go down the middle, halfway down, then we can say that A is 1. So we know this whole side is 2, but half of that side is 1. So we know A is 1, and let's look at what B is of this triangle on the left. And we can do that by, again, using our Pythagorean theorem. And so we know that the hypotenuse squared, so 2 squared, is equal to the legs, one of the legs squared, which is 1 squared, plus B squared. So we get 4 is equal to 1 plus B squared. Getting B squared by itself, subtracting 1, we get B squared is equal to 3. And taking the square root of both sides, and because it's a length, we're just looking at the positive of the square root, we get B is equal to root 3. Okay, so now that we have our triangle here, we can do our trigonometric functions. So if we look at sine of 60 degrees, so looking at the 60-degree angle, we're going opposite of that side, which is root 3, all over the hypotenuse, which is 2. Cosine of 60 degrees. So this is equal to adjacent of the 60-degree angle, which is our 1, all over the hypotenuse, which is 2. Tangent of 60 degrees. This is opposite, so opposite side of 60 degrees is root 3. All over adjacent, the adjacent side of the 60-degree angle is 1. So cosecant of 60 degrees, that's 1 over sine. So this is 1 over root 3 over 2. So invert multiply, we get that this is 2 over root 3. Rationalizing our denominator, getting rid of the radical in that denominator, we can multiply this by square root of 3 all over square root of 3. So this gives us back 2 root 3 over 3. Secant of 60 degrees. This is 1 over cosine of 60 degrees, so 1 over 1/2, which is 2. And cotangent of 60 degrees. This is equal to 1 over tangent of 60 degrees. So this is 1 over root 3. But rationalizing our denominator here, multiplying by root 3 over root 3, we get that this is equal to root 3 over 3. So we derived all the trigonometric functions at 60 degrees. This would be equivalent to the trigonometric functions at pi thirds. And now let's look at the trigonometric functions at 30 degrees. And so again, there's multiple ways that we can go about doing this. We can use the fact that if we know one of the trigonometric functions, so for instance, sine of 60 degrees, the cofunction is cosine of 90 minus 60 degrees, which is the same thing as cosine of 30 degrees. So we can see that cosine of 30 degrees is the same as sine of 60 degrees. So cosine of 30 degrees, this is equal to √3 all over 2. Or you could have used your triangle. 30 degrees adjacent is √3 for the 30 degrees, and the hypotenuse is 2, which gives us that √3 over 2. So we can do this, though it's easier than just knowing those cofunctions, because we have the 60 degrees, we can get the other ones pretty fast. And so let's just do that. Sine of 30 degrees, it's the same thing as cosine of 60 degrees, which is 1/2. Cotangent of 30 degrees. This is the same as cotangent of 30 degrees. This is the same as tangent of 60 degrees, which is √3. Tangent of 30 degrees is the same as cotangent of 60 degrees, which was √3 over 3. If I look at cosecant of 30 degrees, this is the same as secant of 60 degrees, which is 2. The last one, secant of 30 degrees. This is the same as cosecant of 60 degrees. And cosecant of 60 degrees was this 2 √3 all over 3. So let me just put up a table and of a review of just what we just found. Okay, so in front of you now is that table. So we were looking at the degrees, but equivalent to those degrees, the 30 degrees we have is pi 6. And so our trigonometric functions at pi 6 or 30 degrees, sine of pi 6 or sine of 30 degrees is 1/2. Cosine of 30 degrees or cosine of pi 6 is √3 over 2. Tangent of 30 degrees is equal to tangent of pi 6, which is √3 over 3. Cosecant of 30 degrees or cosecant of pi 6 is 2. Secant of 30 degrees or secant of pi 6 is 2 √3 over 3. And cotangent of 30 degrees or cotangent of pi 6 is √3. And now looking at pi force, our trigonometric functions at pi force or 45 degrees, we get the following. So sine of 45 degrees or pi force is √2 over 2, which is equivalent to cosine of 45 degrees or pi force, which is √2 over 2. Tangent of 45 degrees or tangent of pi force is 1. Cosecant of 45 degrees or pi force is √2. Secant of 45 degrees or secant of pi force is √2, and cotangent of 45 degrees or cotangent of pi force is 1. And then pi thirds, which is equivalent to 60 degrees. Cosine or sine of 60 degrees is √3 over 2. Cosine of 60 degrees or pi thirds is 1/2. Tangent of 60 degrees or tangent of pi thirds is √3. Cosecant of 60 degrees or cosecant of pi thirds is 2√3/3. Secant of pi thirds or secant of 60 degrees is 2. And last but not least, cotangent of 60 degrees or cotangent of pi thirds is √3/3. So you want to memorize at least sine of these angles and cosine of these angles. And again, we can derive the other ones by looking at the relationship of that trigonometric function and sine and or cosine. So there is a trick that can help you memorize these, and it's using your hand. So let me try to explain this. I'm not very good with drawing. So let me come up with a picture really quick, and then I'll talk through how to do this. Okay, so in front of us now we have our hand and we have our thumb. We're going to use our thumb as 90 degrees, which is the same thing as pi halves. Think of our hand as our angles. This one, our pinky, this is at standard position. Standard position was the horizontal on the x-axis pointing towards the positive direction. So this is 0 degrees. And then the ring finger, this is 30 degrees. Which is the same thing as pi 6. The middle finger is 45 degrees, which is the same thing as pi 4ths. And the pointer finger, this is 60 degrees, which is the same as pi thirds. So it depends on if we're looking at cosine or sine. I remember that cosine is starting at the top, my thumb. And sine is starting at the bottom. Which is my pinky. And so when we're figuring out what these trigonometric functions are at these angles, we're counting the number of fingers that we're using to get to that angle. And so if we're looking at cosine, we're counting down how many fingers it takes to get from my thumb down to that angle. And if we're looking at sine, we're looking at how many fingers it takes to count up from my pinky to get to that angle. I remember cosines at top, sines on the bottom, thinking of the alphabet, that C comes before S in the alphabet. So that's just how I remember which one goes where. And so looking at this, if we wanted to look at let's look at sine. Sine of 30 degrees. I'm looking at how many fingers I would count from my pinky to get up to the 30 degrees. Well, this is just one finger. The formula to get our trigonometric function is we're looking at square root of n all over 2, where n is equal to the number of fingers. It takes to get to the angle. And so it's only one finger to get to 30 degrees. And so that's n is going to be 1 there. And so we would have here that this is the same thing as the square root of 1 finger all over 2. Well, square root of 1 is 1, and this is 1/2. Where if I was looking at cosine of 30 degrees, cosine, I'm starting at my thumb, and I need to count down to the 30 degrees. And so this is 1 finger, another finger, another finger. And so in this case, I'm counting 3 fingers to get down to 30 degrees. And so my formula, my n is 3, so it's square root of 3 all over 2. So if we're looking at sine of 45 degrees, well, from 0 to 30 degrees is one finger, 30 degrees to 45 degrees is another finger. And so counting the number of fingers, there's 2 of them, so it's square root of 2, all over 2. Cosine of 45 degrees. If I'm looking at my thumb and counting down to 45 degrees, I have 2 fingers to get down there. And so this is square root of 2 fingers all over 2. So sine of 60 degrees. So going from 0 degrees to 60 degrees, there's 3 fingers. So this is root 3 all over 2. And last one, cosine of 60 degrees. There's only 1 finger to get down to 60 degrees. And so this is root 1 over 2, which is 1/2. So it actually even works for 0 degrees and 90 degrees. So let's just do that since we have our hand in front of us. So if we were to look at sine of 0 degrees, well, I'm not moving any fingers from 0 degrees. And so n is 0 in this case. And so this is equal to square root of 0 all over 2. Well, square root of 0 is 0, and 0 over 2 is 0. Cosine of 0 degrees, counting the number of fingers down, from my thumb down, I have 1, 2, 3, 4. So this is equal to square root of 4 all over 2. Well, square root of 4 is 2, and 2 over 2 gives us back 1. If we wanted to do sine of 90 degrees, counting the number of fingers from our pinky, we have 1, 2, 3, 4. And so this is equal to root 4, which is 2, all over 2, which is 1. Same idea, cosine of 90 degrees. This time we're starting at our thumb. We're not moving anything, so our number of fingers is 0. So square root of 0 over 2 is 0. So there's just a little trick to help you derive those trigonometric functions pretty fast. And then again, we can always derive the other ones, knowing what sine and cosine is. And just as a reminder, we know that tangent of an angle theta, this is equal to sine theta over cosine theta. We know that cotangent theta, it's the reciprocal of tangent theta, which is cosine theta over sine theta. Secant theta, this is the same thing as 1 over cosine theta. And cosecant theta is the same as 1 over sine theta. Okay, so let's look at a couple more examples. Knowing now these angles, we can evaluate trigonometric functions at these angles. So we have the following examples in front of us. We have sine of 60 degrees times cosine of 45 degrees. So sine of 60 degrees. So if I'm looking at my hand, 60 degrees sine is going up. I'd have 1, 2, 3. So I know that's root 3 over 2. And so this is root 3 over 2. All times cosine of 45 degrees. Cosine starting at the top, 45 is down here. So we'd have 1, 2. So this is root 2 over 2. So simplifying this using rules of fractions and radicals, same index, we have square roots. We can just multiply underneath the radical. So square root of 3 times square root of 2, this is root 6. all over 2 times 2, which is 4. So tangent of pi 6 is 30 degrees. You can look at it as sine of pi 6, if you need to, all over cosine of pi 6, plus, well, cosine of 45 degrees, we just saw that above, that was the root 2 over 2. So pi 6, 30 degrees, it's right here. So sine of pi 6, this is 1/2. All over cosine of pi 6, which ends up being root 3 over 2, plus root 2 over 2. So we're looking at 1/2 divided by root 3 over 2 is the same thing as times the reciprocal, 2 over root 3 plus root 2 over 2. I notice that my 2's cancel. Also notice that I need a common denominator and I need to rationalize the denominator. So let's first rationalize the denominator for that first grouping. And so we can multiply that by root 3 over root 3. Fancy one. And this would give us root 3 over 3 plus root 2 over 2. Common denominator would be 6. So getting a common denominator, I would need to multiply that first fraction by 2 over 2. And I would need to multiply that second fraction by 3 over 3. And so when we do this, we have a common denominator of 6. So we can put this all over 6. We have 2 root 3 plus 3 root 2 all over 6. So if, for instance, this was on an exam, I wouldn't allow you to have a calculator. You would leave your answer like this. If you're doing your homework, they might ask you for the exact answer, which would be this. And then they might ask you also for an estimate. So plugging that in the calculator and rounding. So this last example in front of us, scrolling up, is tangent squared of pi 4 plus sine squared of pi 6. So the way that this is written, this is the same thing as looking at tangent of pi 4, evaluating that, and then squaring it. This is the same thing as looking at sine of pi 6, evaluating that, and then squaring it. So tangent of pi 4, that one is, if you remember, was 1. It's sine of pi 4 over cosine of pi 4, which is root 2 over 2 divided by root 2 over 2, which is 1. So this is 1 squared plus sine of pi 6, sine of 30. That one was 1/2. And we're squaring it. So this gives us 1 plus 1/4. Common denominator. So that's 4/4 plus 1/4, which gives us back 5/4. Okay, so unfortunately, you can't get the calculator showing up on the screen with this page in front of you. And so the only thing that you really need to be careful of is when you're in your calculator, make sure that you're either in degrees or in radians, depending on what the problem is. So in this first example, I have cosine of 53 degrees. I would go and make sure I was in degree mode, which in my calculator I am. And you would just go to your trigonometric function. In this case, it's cosine, and I would just type in 53 degrees. And rounding that, I would get that this is here is approximately 0.60. So cosecant of 68 degrees. Our calculators have sine, cosine, and tangent. They don't have cosecant, so we can rewrite this in terms of sine. This is the same thing as 1 over sine of 68 degrees. So I would go to my calculator and I would go 1 divided by sine 68 degrees. And this was going to give us approximately 1.08. And then tangent of 5 pi 12ths. That is in terms of radians. So I need to make sure that my calculator is in terms of radians, and it's not because we were using degrees. So I would put it into radians, and then I would just go to my tangent, 5 times pi, your calculator should have pi on it, all divided by 12. And so doing that, we get that this is approximately 0.023. So if you have any questions on the calculator piece, then you can always come and see me during student hours and I can help you. So you'll have some calculator exercise on the homework. And now let's look at some applications. But I'm going to start the video over for applications, or start a new video for that. So let me just pause or stop this video, and then we'll start a new video to do the applications.